Hi, and welcome to this week's lesson on straight line graphs. This is lesson 14 from my GCSE preparation course, and we're moving on to straight line graphs so that we can go back to some inequalities and shading regions next lesson, because that's what we looked at last week, but I thought we could all do with a little recap of this topic. There is a lot of content in this topic, so I've chosen some of the main sort of questions that might come up to really kind of do that just revision, so quick going through of each type of question. I'd like to start with some midpoint questions, so they're on the right here of this slide. Have a little go at the top two. If you'd like an extension for a rainy day, then have a go at the extension there, which is revealing a picture by plotting some coordinates. Okay, I'm just going to give you 1 minute while some people are logging on and joining us to have a go at questions 1 and 2. Off you go. Just a reminder that if you need help at any point during this session, just type in the comments or the chat box and I'll get back to you as soon as possible. And you can find all of my previous lessons on my YouTube channel, Facebook page and my website, mrsk'slightbulbmoments.wordpress.com. You can download the handouts, so all the kind of question bits that need writing on before the session goes live, and then you can watch along with the video to see the solutions. Right, finish up the question you're doing for me. Let's see how we are. All right, should we look at question 1 together? So find the midpoint of this line segment. Now, the scale is really important here. Our first point is actually at 0.51 and our second point is at 3, 4. Now that's because if you see each, we've got sort of 4 gaps there, or can't think of the word, parts before the 2. So we've got to divide that by 4. So each line there, or each jump, is 0.5. Be careful because you're used to seeing 5s. Often things are split into 10 or 5. So I actually assumed that was a jump of 5 rather than 4 when I was doing this the first time round. So be really careful looking at the scale whenever you've got a question like this on a set of axes. So 0.51 and 3, 4. Finding the midpoint. Now, as it's drawn on a nice grid here, we've got nice big squares, we could actually just count. So if you count along with me, just going right, so we're going along the x-axis, we're going 1, 2, 3, 4, 5. And now I lined up with the top one. So half of that would have been 2.5. 1, 2.5. We end up here, follow it all the way up, and that means our midpoint would be there. So you can just count squares if it's there. You can test it by going the other direction. Let's count here, going upwards. 1, 2, 3, 4, 5, 6. So that means halfway would be at 3. So start again from the bottom. 0, 1, 2, 3, halfway. Count across until you hit the line and we get the same point, which is in fact the coordinate 1.75, 2.5 if we focus on our scale. So you could just do it visually, but I want to make sure you know how to do it not visually as well. So if we look at our numbers here, our change in x goes from 0.5 to 3. So that is a difference of 2.5, okay, a difference of 2.5 in our x values. So our midpoint is going to be halfway. So if we divide that by 2, we get 1.25. So that means we would have to add on 1.25 to our x value to get our midpoint. 0.5 plus 1.25 does give us our 1.75. You could also do that with your y value. So to get from 1 to 4, we need to go up 3, 1 from 4. We don't want to go the whole way, we want to go halfway. So 3 divided by 2 gives us 1.5. So we need to actually go up from our first point, and we need to go up 1.5. So 0.5 plus 1.5. Oh, where have I gone wrong there? Not 0.5, sorry, 1. I'm looking at my wrong coordinate there. 1 plus 1.5 does get us 2.5, which is what we had up here. Okay, so either visually, but you do need to know how to do it from just the coordinates as well, because you might get a question like this. Find the midpoint of the line segment connecting points -4, 7 and 5, -4. Now the answer is 0.5, 1.5. Let's just check we're happy with getting that. So our difference between x on our first point and x on our second point, so we might call this x1 and x2, is 9. So a difference of 9. Halve that difference and we get 4.5. So that means we have to add 4.5 onto our first coordinate to get to that midway point. And can you see that's how we get 0.5? -4 plus 4.5. If we did that with our second point as well, so our y value, y1 to y2, that actually goes down 11. You see it's going from +7 down to -4. So it's going down 11, so I'm going to write that as -11. But we want to divide that by 2, so we get -5.5. So that means we have to subtract 5.5 from 7, and we get 1.5. There's loads of different ways to do this as well. You could think of it as like an average. If you've got 2 points and you want to find the middle, that is the average. It's the mean and also the median in that case. So you could add them together and divide by 2. So in the first case, -4 plus 5 is 1, divided by 2 is 0.5. And in the case of the y values, 7 plus -4 is 3, divided by 2 is 1.5. So that was a bit of a quicker way if you've managed to spot the link between just finding the average of your x values and the average of your y values. Okay, whatever way you do it, absolutely fine, but I've shown you 3 different methods there, so hopefully one of them works for you. That's just finding the midpoint. I'd always check it makes sense as well. If you've got a wordy question like number 2, do a little sketch and see if it makes sense that your point would be there. Okay, I'm not going to go through the extension there. If you want a little go at it, I would recommend it. It's quite a nice one that comes out as. Email me for the solution or send me a picture of what you've got. I'd love to see it. Okay, let's get on with the content then. Now, I did tell you there are a lot of topics in straight line graphs. This is just some of them. I'm not going to go through all of them reading out loud, but we will try and cover all of them today. As I said, it's going to be quick. All right, let's get on with it. So, calculating the gradient between 2 points. We might have a question like this, and we've got to work out the gradient. Now, whichever way you remember it, you might remember gradient equals rise over run, or change in y over change in x, dy over dx. Anything like that to help you remember that it's the difference in the y values divided by the difference in the x values. So, if we have a look at our graph here, our difference in our y values, so our rise, is we're going up from this blue point to the green one. So we're actually going, and we can view our triangle. You can do it on top of the line or under the line. It doesn't matter which. I'm just going to draw our right angle triangle here for us. Now our rise, and check your scale really carefully here. Each square is 1 on both the x and the y. It's important to check that because it could actually be different on the x and y axes. So I've got to check. 1, 2, 3, 4, 5 is my rise, so my difference in y, and my difference in x is 3. So that means my gradient would be 5 over 3. Okay, you don't need to simplify it, you can leave it in its fraction form like that. An improper fraction is absolutely fine for gradient. Okay, let's try the next one. So this one here, what would the gradient of that one be? Now this is the kind of question, it might throw a few of you, because can you see the last point, that green one, is halfway between 2 squares. Now it looks like it's halfway between, we don't know whether it is exactly halfway between. So always look for ones which are on an exact intercept. You see this bit here? That's on an exact intersection, and this original one. So draw your triangle between those 2 points. It doesn't have to be the beginning and end of the line segment. So here our rise is 1 and our run is 4. So our gradient is 1 over 4. You can see it's quite a shallow line there. Okay, so just look out for where to draw those triangles. Next one. Have a go at that one. Okay, now I wonder if I caught some of you out here. If we draw a triangle, and remember we're kind of reading the line left to right. If we go along, we've gone, I'm going to draw my triangle here because that's a nice intersection. I don't need to draw it the whole way. But I've gone across 1 and I've actually gone down 3. So I'm going to write myself a -3 there. Then my rise over run, so the rise, or the difference in y, is going to be -3. My run is 1, my difference in x. So my gradient is -3. Okay, it's a negative gradient. My line is sloping downwards, downhill there. And it just helps if you actually write those negatives on your triangle. So if it's going down, and you think of the scale there, if you look to the actual y values, we started up here at the top on a y value of 7. At the bottom of my triangle, we're on a y value of 4. So our y value has decreased by 3. Our x value has gone up by 1, gone from 4 to 5. Okay, let's try another one. What would we get for this one? What gradient? Okay, so choose your triangle. I'm just going to choose this little one down here. We've got a rise of 2 and a run of 1, so that's 2 over 1, which is 1. Okay, nice gradient. Sorry, which is 2. A nice gradient of 2 there. A nice positive one. Next one. Have a go at that. Okay, draw your triangle in. Here, it does make sense to go all the way to the end because that's where it's right on the cross. We've got a difference of 1 and a difference of 1, 2, 3, 4, 5, 6. So it is 1 over 6, my gradient. Still nice and positive there. Okay, what about this one? Okay, I'm going to choose to draw my triangle here. And it's gone down 2 and along 3. We were happy that's gone down that time. So my change in y was -2. My change in x was over 3. You can just write the negative in front of the fraction. Okay, that is -2/3. What about this one? So I've taken away the picture, I've just given you the coordinates. What's the gradient? Okay, this time it makes sense to look at this a little bit more rather than thinking, what was my rise, what was my run? So our rise was our change in the y values. Now remember, coordinates are alphabetical, it's x then y. So our y values went from 5 to 7, so they added 2. Our x values went from 2 to 8, so added 6. So our gradient is 2 over 6 or 1/3. Okay, just make sure you're going from one coordinate to the other in both cases, the same direction for x and y, and you shouldn't make any negative errors. Let's try one more of those ones. Have a little look at that. You have a go. Okay, so my y value, again remember x then y, so y value has gone from 4 to -2. So it's actually gone down by 6. My x value has gone from 1 to 5, so it's gone up by 4. So I've got -6 over 4, so I know it's going to be a negative gradient. 6 over 4 simplifies to 3 over 2. So that would be my answer, -3 over 2 gradient. Okay, so it's a quick run through some of those. Let's have a look now at horizontal and vertical lines. So have a look at my first one there. Hopefully you can see that blue line. Is the equation of that line x equals 2? True or false? What do you think? Yes, it is actually true. Every x coordinate along that line would equal 2. So if I put a point anywhere on that line, here, 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 as long as it's on that line, the x coordinate would be 2. It would be 2 and then something, depending on how high up or low down the line it is. So that's why our equation is x equals 2, because everywhere along the line x equals 2. What about this next one then? Is that the line y equals minus 2? No, it is not. What line is that? Good, it is x equals minus 2. So it's not y equals minus 2. Along that line, every x coordinate is still minus 2. Now, what about this next one? Is this the line y equals 2? No, it is not. What is the equation of that line? Y equals minus 2. Okay, be careful there, that's going through negative 2. So everywhere along that line, y value would be minus 2. Okay, and the last one, is that the line y equals minus 0? Now this is technically true. We wouldn't normally write it like that. Normally we would just write y equals 0 because we don't need minus 0 or negative 0. It is just the same as 0. But it's not wrong saying y equals minus 0. But anywhere along that line, the y coordinate would always be 0. The x coordinate would change. So it's just remembering those ones. If you struggle to remember which one's vertical, which one's horizontal, because some people think the vertical lines are y equals because it looks like the y-axis. But remember, that means it's sort of following the y-axis and not cutting through it. The way I tend to remember it is where it's cutting through. So that first one is cutting through at x is 2. This one is cutting through at x is minus 2, which is why it's x equals minus 2. This one is cutting through the axis at y is minus 2. And this one is cutting through the axis down there at y equals 0. Okay, I hope that's helped with those. Quick few for you to practice. So as many as you can. If you've got this printed out, try and circle on them true or false. If not, do a little tick or a cross. I'm giving you about 30 seconds, really quick. Off you go. And 10 seconds. And answers coming up. All right, check your work, see how you did. All right, well done. If you got any wrong, I'd suggest pausing this, going back, listening to my explanation again, and having another go. Really think about where it crosses that axis or what the coordinates would be. Try jotting down, for example, in this top one, try selecting 3 coordinates and write down what they have. So this top one would be the coordinate 2, 3. The middle one would be 2, 0. And the bottom one would be 2, minus 4. What do they have in common? X is always 2. Okay, so that is the line x equals 2. Okay, quick way to do it if you're stuck. Right, next topic then. Finding the equation of a line from a graph. I'm hoping we are familiar with y equals mx plus c, where m is the gradient. I like to remember this, m for mountain, gradient, steep, somewhere like that. And c is the y-intercept. There's actually a c in the middle of intercept. Okay, anything if it helps you remember it at this stage. Y equals mx plus c. So that means we need to find 2 things to know our equation of our line. We need to find the gradient and we need to find the intercept. We know how to find the gradient, we just did it earlier on. So we need to find a triangle somewhere that goes exactly, I'm going to choose this one here. Yeah. Look at your difference in y. Again, look at your axes and your scale really carefully. That's gone up 3. The difference in x is gone across 1. So my gradient is 3 over 1, which is 3. So instead of m, I can write 3x, okay, because I know my gradient is 3. Now my y-intercept is where the straight line cuts the y-axis, and that is here at 1. So it's plus 1. So that's your equation. I'm really hoping that's a quick recap for you. Y equals mx plus c, find the gradient, find the intercept. You have a go at this one, please. And let's go through it. So your triangle, again, you could have chosen a triangle anywhere. The smallest one is a 3 by 1 triangle. So that is again a gradient of 3, a y-intercept of -1 this time. So our equation is y equals 3x minus 1. You should be able to tell those are parallel lines. We haven't changed the steepness of that line at all. It's just moved down the graph as a way, or kind of along it might look like. So the y-intercept has changed. Okay, what about this one then? I'll do this one with you. So firstly, let's think about where we're going to draw our triangle. Again, doesn't matter as long as you try and get it on 2 points that cross exactly. I'm going to draw mine there. Now this time it's gone down 3 and across 1. So that means my gradient is -3 over 1, which is -3. So y equals -3x. See, my y-intercept is actually still here at 1. So plus 1. So y equals -3x plus 1. So just be careful if it's a negative gradient. You have a go at this one. And let's go through the answer. Our triangle was exactly the same, gradient of -3, y-intercept of -1, so your equation was y equals -3x minus 1. Okay, super. I'm not going to give you long on these, so if you feel like you need a bit more of that basic practice of that sort of type of difficulty, try questions 1 to 6. If you're really okay with that and you're just warming up, go straight into those challenge questions. Find the equation of each line. If you've got these printed out, you might find them easier to see. Okay, but I'm just going to give you maybe half a minute. I'd be impressed if you do one of the challenge questions then. Okay, finish the one you're on. If you're watching this after the session is aired, do pause it. Take as long as you want on these. Make sure you're confident. And answers coming up. Okay, take a moment to mark what you've done. Now on the challenge questions, I'm not going to go through those now. If you have had a go but didn't get that, keep watching because I'm going to cover the skills you need for it, but I'm not going to tell you explicitly how to do them because I want you to be able to imply that from what we now move on to. Alright, so after the video, come back and try them again. Let's move on then. So, what if we're asked to show that a line will pass through a point? So look at this first example. Show that the line y equals 4x plus 7 passes through the point -2 minus 1. So this can be a bit confusing because you're used to your sort of certain methods for certain types of questions, and then you're thrown this one which you haven't done before. But I always say to my students, if in doubt, put a little x and a y above your coordinates, because quite often you forget that those are two possible values you could use. Because we know that if the line goes through this point, that means that when x is -2, y is -1. So we can now use this information to test it. So pop that coordinate back into the formula. So instead of y, we can write -1 equals 4 lots of x, but instead of x, we're going to write -2. So 4 lots of -2 and then +7. So I've just substituted in to my equation. Now leave the left-hand side like that. The right-hand side, 4 lots of -2 is -8. +7. What's -8 plus 7? It is -1. Fantastic. So because that is true, it means the point does lie on that line. The sort of x and y are in that relationship with each other. If you multiply x by 4 and you add 7, you get y. Okay, so it's just testing whether they work in the line equation. Slightly different wording for your one. Can you have a go at that? So does the line y equals 3x minus 2 pass through the point -5 minus 13? And let's have a look. Oh, sorry, turn the stars off. So we substitute in, just like we did before, our coordinates into our equation. And when we simplify it, we get -13 equals -17. So no, the line does not pass through the point. Okay, so our first one, you see the slight difference, that was a show that. So we knew it did pass through the point, we just had to show it clearly in a method. The second one was asking whether it did. So we had to work out whether, if we put those numbers in, it would work in that equation. It doesn't work in the equation, so it means that that coordinate does not sit on the line. Okay? You've got to be really careful with your method here and how you're showing it. This isn't something you can just do in your head, especially a show that question. It has to be really clear. Okay, next one. Find the equation of a line from its gradient and intercept. So let's have a look at our first question. Find the equation of a line where the gradient is 4 and it passes through 0, 5. Now we're off to a good start here. Gradient is 4. Well, I know y equals mx plus c. That means it must be y equals 4x because m is my gradient. Now, do I know c? It doesn't say the intercept is something, but it does say it passes through 0, 5. If we picture that on a graph, 0, 5 is going to be up there. So that is actually the y-intercept. If there's a 0 here, you know that this value is your y-intercept. So my equation is y equals 4x plus 5. I don't have to do any complex math there. I'm just putting the 4 where it needs to go in front of the x and my y-intercept from my coordinate at the end of my equation. Okay, you have a go at that one for me. Yeah, we should have got y equals half x minus 7 because the gradient was half and our y-intercept was -7. If you're stuck on this question, remember what I said, put your x and your y above those coordinates, but also always draw a sketch if you're stuck. Okay, you don't need to waste time doing a sketch if you know exactly what you're doing. But if you get to a point like that, a sketch can really help because straight away we saw that that was the y-intercept. Okay, this is slightly trickier. Find the equation of a line where the gradient is 3 and it passes through 2, 1. So again, let's start off like we did before. Y equals, my gradient is 3, so 3x, I know that. I don't know c. And remember, that's not my y-intercept because it's 2, 1, not 0, 1. So I don't know c yet, so now I'm at a little bit of a sticking point. What was the first hint I said if you're at a sticking point? Write x and y next to your coordinate. Remember, that is a set of values you can put in. So let's try and substitute it in. If y is 1 and x is 2, let's do some simplifying. 1 equals 6 plus c. C must be -5 because 6 minus 5 gives us 1. So now my equation is y equals 3x, because we already knew that gradient, and we've just found c is minus 5. Okay, so what we did there was we started off by putting in what we knew, the gradient. We left it as plus c because we didn't really know that, but we just tried substituting in our x and y values, and suddenly they got rid of 2 of the letters we didn't know, so we were just left with the c, and we could find that out. Okay, you have a go at this one then. All right, should we have a look? So you put in what you know, we get y equals minus 2x plus c. Substitute in that coordinate, your x and y values, and we get 1 equals 6 plus c, and we get c equals minus 5 again. And then your actual equation would be y equals minus 2x minus 5. So I want to stress here that I'm not teaching you, oh, this is the method you do for this exact question, this is the method you do for this exact question. The questions, they could change. You could be thrown into a situation where you see a question you haven't come across, or you might muddle up your methods. It's not the best way to learn maths. But instead, try and have different problem solving skills or kind of tools in your toolbox that help you solve the questions. So things like substituting in what you know, putting in your gradient, for example, writing down the x and y and then substituting those in as a pair of values, drawing a quick sketch so you can see what those look like. These are all skills that will help you in any of these type of questions. Okay, well done if you're keeping up so far. Next one, find the equation of a line from its y-intercept and any point. So in the previous one we did gradient and point. This is exactly the same. So I'm not going to stress on this too much because remember we're not learning a whole new method for this. It's just start by substituting what you know. So this time I don't know my gradient, but I do know my y-intercept. So y equals mx, I'm going to write because I don't know the gradient, but my y-intercept is 3. Okay, so I do know that. And then remember, I know my pair of values, x and y. So let's put those in. 3 equals m lots of 2 plus 3. Now you've got to do some rearranging. Take away 3 from both sides. 0 equals, no, we could write that as 2m rather than m lots of 2. So divide 0 by 2, we get 0. That means m must be 0. Well, if your gradient is 0, we get 0 lots of x plus 3, but 0 lots of x would just be 0. So my equation would just be 3. Y equals 3. Okay, so that is actually a horizontal line going through the y-axis at 3. And if you look back at the question, it makes sense. If your y-intercept is 3, so you know that on your graph it goes through the y-axis at 3, and then it also goes through the point 2, 3, then it's just going in a straight line that way. Okay? Right, you have a go at this next question. So remember, plug in what you know, plug in that pair of values and see what comes out. Okay, finish off what you're doing. And let's check your work. We should have got y equals mx minus 8, then substitute your values in. 4 equals m lots of minus 3 minus 8. So m would be minus 4, because 12 divided by minus 3 gives you minus 4. That means your equation will be y equals minus 4x minus 8. Okay, I hope you got that one. Look back at my workings there to see it might have been a negative error if you did that, or a rearranging an equation error. So just be really careful which was our stumbling block. Super. Okay, well done. Now have a little look at this one. We're going to use some of our skills from before on this. So find the equation of a line that passes through the points 3, 5 and 5, 13. Do we know our gradient or our y-intercept from those? Now we don't straight away know our y-intercept because neither of the values goes naught something. But could we work out our gradient? Yeah, we did one of these earlier on, didn't we? So the gradient is the change in y over the change in x. So remember we've got x, y. So our change in y, it's gone up 8. And our change in x, it's gone up 2. So our gradient is 8 over 2. So that's, m is what we're working out, which is 4. So I do actually know my gradient, so I can write y equals 4x. Don't know my intercept, so keep that as plus c. Now what do we do when we get to this stage? Plug a set of values in. Now you've got 2 to choose from. Both of them would give you an answer, and they'll give you the same answer, because it's that relationship that they share, it doesn't change. But I would probably want to work with the 3 and the 5 rather than the 5 and the 13, because they're smaller values. So I'm going to substitute in y is 5 and x is 3. So 5 equals 12 plus c. C must equal, sorry, running out of space, minus 7. So therefore my equation is y equals 4x minus 7. Now, can you work out how you would check that answer? Because this question is quite nice. It gives us a way to check it. Yeah, look at that other coordinate. Try and put that one in now. Do you remember when we tried to show whether that point was on that line? So is the point 5, 13 on this line? So that means that if y was 13, 4 lots of 5 minus 7 should also be 13. 20 minus 7? Yeah, 20 minus 7 is 13. Fantastic. So you just checked your own answer there by using your other coordinate set. So you could have used either of them. You have a go now, see if you can do that question. Alright, should we see what we've got? So I hope we've got a gradient of minus 5. Now be really careful here. The 7 to the 2 went down by 5, whereas the 2 to the 3 went up by 1. So our gradient was minus 5. Put that and the first point into your equation. Again, you could have chosen the second one. I chose the first one there. Oh, sorry, that's a little mistake there. That should have been a 0, not a negative. But we get 7 equals minus 10 plus c. So c equals 17, yeah. And then when we write that out as our equation, we get y equals minus 5x plus 17. And you could check that with your second coordinate if you wanted. Okay, well done if you're still following me. I told you there's a lot of content here. It's a bit of a whiz through. Now we can try something a little different. So a little bit of a break from all that. And we're going to come back to one more question after this. Okay, so we're nearly there. This is the bit that a few people often get stuck on, and it's parallel versus perpendicular. So parallel lines, like train tracks, they have the same gradient. They will never meet. Okay, exactly the same steepness, same slope, same slant, whatever you care to think of it as, same gradient. So if you think about our equation, if this example, y equals 3x plus 5, they will always have that same gradient. The 3x will be the same. Now, perpendicular lines have gradients that are the negative reciprocals of each other. So let's have a look at what that means. So our negative reciprocal means something times by a number, and that's what we need to find, will give us minus 1. So for example, if we want to find the negative reciprocal of 5, we need to work out 5 times what gives us minus 1. Now, I find sometimes the best way to think of this is in fractions. So how could you write 5 as a fraction without changing it? Yeah, 5 over 1. Okay, you often do this when you're multiplying or dividing fractions as well. Times something will give you -1. Now, -1, we're going to have a little minus there, but it could be anything over anything. So do you agree that -1 is the same as -5 over 5? Yeah, 5 divided by 5 is 1, so that is -1. Now, what would I have to multiply 5 by to get 5? Or to get -5 specifically? -1. What would I have to multiply 1 by to get 5? 5. So we just put a minus in front of this whole fraction because we're basically multiplying the first fraction by a negative fraction, which will get us a negative answer. But on the top, the numerators, we've got 5 times 1 is 5, 1 times 5 is 5. We've got a negative in there. Now, can you see we've actually just flipped that fraction? This means our negative reciprocal is -1/5. So if we had an answer of 5 to start with, our negative reciprocal becomes -1 over 5. So the above reason is kind of how it works, how that gets you to -1. But if at this stage you're just after a little sort of trick in a way, a little sort of memory tip, then write it as a fraction. So if it's just a whole number, make it over 1. Flip it and flip the sign. So if it was positive, it becomes negative. And if it was negative, it would become positive. If it's 5 over 1, it becomes 1 over 5. If it's 1 over 5, it becomes 5 over 1, or just 5. Okay, it's easier if you practice it. So can you have a go at these questions? These are your original gradients. I want you to find the perpendicular gradient. So we're finding the negative reciprocal. Use that little trick if you need to. Flip the sign, make it a fraction and flip it over. Okay, should we have a first few answers coming up to check you're on the right path? We should get -1 over 2. Remember, flip the sign, flip the fraction. What if the gradient was 1? Flip the sign, we know it's going to be negative. It would just be 1 over 1, which is just 1. Next one, 1 over 5 would actually become -5 over 1, or just -5. 2/3, because it was positive, we know it's going to be negative. And flip the fraction, it's -3 over 2. Last one was negative, we know our answer is going to be positive. It was 7 or 7 over 1. So when we flip it, it's going to be 1 over 7. Okay, so whether you understand the kind of the meaning behind that or whether at this stage you want that quick trick, I hope that's helped you be a bit more confident parallel versus perpendicular. Now I'd like you to try this little task for me. And it's about really spotting some of these connections between the equations of a line and what they mean, but also testing your rearranging skills, something that comes up a lot in any type of equations question, but also equations of a straight line. So I'd like you to group these equations into those which would be parallel to y equals 3x plus 5, those which would be perpendicular to y equals 3x plus 5, and those that would be neither. So I'm going to give you about a minute for this because I'd really like you to have a good go at some of these now. I'm not going to give you a chance to do all of them because it might take you quite a lot longer. So I really would recommend pausing this after the session and going back to it, doing it in your own time, because this tests so many different skills and misconceptions in maths. All right, so see if you can see if you can find one from each column. That's your task for now. Off you go. Okay, not long left now. I'm hoping you might have managed to find one from each column. Alright, answers are going to come up. Remember, do make sure you pause to see if you have got time and work through it because it's a really good task. Okay, those are the right columns for them, so where they should be: parallel, perpendicular and neither. If you're struggling on it, start from this page and try and work out why those ones are parallel, why those ones are perpendicular and why those ones are neither. So the hint is to rearrange them all into the format of y equals 3x plus 5, because we can only read off the gradient when it is in this format. The y is on its own on the left hand side, just one y, not 2y, not 3y, not half y. And then we have our x's and our extra numbers there that intersect on the right hand side. Okay, well done. I told you there's one more. Okay, let's see if we can do this one now. Find the equation of the line perpendicular to y equals 3x plus 2, which passes through 6, 5. So, what do we know? It's perpendicular to y equals 3x plus 2. So this line has the gradient of 3. So remember before when we did the negative reciprocals, what's my perpendicular gradient going to be? Minus 1 over 3. Well done. Okay, the negative reciprocal there. So now we can fill in that information. We've got y equals minus 1 over 3x. Do we know the intercept? No, and this is a common mistake. We know this intercept, but it wants the equation of the line perpendicular to this one. So it's not going to be that intercept. Okay, we don't want that intercept. So we don't know that information, so we're just going to write plus c. But we do know our coordinate value because it passes through 6, 5. So that means when y is 5, x is 6. Still don't know c. Now I can do some rearranging. 5 equals minus 2, because minus a third of 6 is minus 2, plus c, so c would equal 7. So my equation, if we put that all together, is y equals minus a third x plus 7. Okay, so really careful. The most common mistake, I think, is finding c in that original question. But remember, that was c of that line. We want the line perpendicular to that. If you imagine two lines here, we've got one going that way, perpendicular line. It could be anywhere down here. It's not necessarily going to have the same y-intercept. It might do, but it not necessarily. All right, you have one go at this kind of question then. Find the equation of the line perpendicular to y equals minus 2x plus 3, which passes through 6, 7. Okay, should we have a look through that method? So hopefully you got your perpendicular gradient of positive a half, so y equals half x plus c. Substitute in your coordinate value. C pops out as 4, which means our equation is y equals half x plus 4. Okay, and again, there's nothing new to this method here. We know the perpendicular rule, kind of a negative reciprocal, so we're using that, but we're doing the exact same as before. We're substituting in what we know. We're using that coordinate value and we're seeing what we don't know, so in this case the c, we can solve. Okay, great work there. I'm not going to give you a chance to do this now, but I'm going to leave it on the screen so you can pause it if you want to have a go. This is mixed practice. The questions look the same, but they're asking very different things, so it really challenges your brain to think carefully about what the question is asking. Okay, pause it now if you want to have a go, because I'm going to move on to the answers. Answers coming up. Pause to mark your work. Any questions or queries, pop them in the comments and I'll go through it with you if you need that. And final task, this is an application question. Again, not going to do this now, so pause it if you'd like to have a go. It's important you know how to use these skills in a different type of question and how to actually relate them to a scenario. So pause it, have a go. Answers are coming up. And here you go, I'm walking you through my answers here, how I've done them. And part B. Okay, fantastic. Well done today. I know it was a long session, if you saw all I had to fit in at the beginning there, but it's a bit of a whiz through of different types of questions that can come up. That is not every single question that could come up on straight lines. Remember, they can always throw in new ones, test you new skills, but those, I hope, I've given you the problem-solving skills that you need to tackle a question, even if you've never seen it before. You know the skills you need to have. All right, as always, you can download any of the resources from my website. Further practice questions can be found on Corbett Maths, anywhere between 185 and 198. The next lesson is this Wednesday on the 8th of July, 5 p.m, and we'll be looking at graphical inequalities. So combining our skills from inequalities and what we've learnt today from our straight line graphs. And that will be our last lesson of this session and this course. So I really hope it's been useful to you, and I hope to see a few of you regulars at that last session as well. All right, see you then.